Hello students, welcome to Sarasa classes. Today we are solving chemistry 2021-22 NSEC paper. We have to attempt 30 questions over here, part 1 A1, and out of which only one of the option is correct over here. And you have to bubble out the correct option. 1 mole of neon gas is given, which is 20 gram per mole, and 1 mole of argon is given, which is 40 gram per mole. They are stored in two separate containers, 1 and 2, at temperature T and T2 respectively. If the gases are assumed to behave ideally, then we have to find out the kinetic energies and the average velocity. So kinetic energy for the gases we know is 3 by 2 RT. So kinetic energy for container 1 will be 3 by 2 RT, and kinetic energy for container 2 will be 3 by 2 into 2t. So say this is equation 1 and this is equation 2, then it will give us kinetic energy 2 is nothing but twice of kinetic energy of container 1. Obviously of the molecules I meant. And for C average, we know the formula is 8 RT by pi m. So for kinetic energy, C average for container 1 will be what? We will say T remains as T and the neon is the gas over here. So it is 20 pi, and for kinetic, the C average for container 2 we will say using the same formula 8 or 2T, okay, 8 or 2T divided by 40 pi, because the gas molecule in container 2 is nothing but the argon. And now if we compare, we will say both the average energies, average velocities for the gas molecules in container 1 and 2 are the same. So average velocity is same, but the kinetic energy of container 2 molecules is double the kinetic energy of container 1 molecule. So over here, option C is the correct option. An aldehyde ketone in the presence of a base forms a carbon ion at the alpha position, which can react with the carbonyl group in aldol type reaction. It can also react with the olefinic bond, like a Michael type of addition reaction, which is activated by groups like COC and NO2 attached to the double bond. The latter reaction is an addition reaction across the double bond. Violent mixture ketone is an important synthetic intermediate used to synthesize many compounds. So we have to find out basically over here the pair of starting materials suitable for the preparation of this ketone through a base catalyzed reaction. So basically what they are asking is to disconnect this compound, and that is what I am going to show to you. Okay. So while disconnecting this compound, first remember you have to disconnect the alpha beta bond of the unsaturated ketone. So this is the alpha position and that is the beta position. So you disconnect the bond over here, and that gives you minus minus, because you're doing a heterolytic cleavage, plus plus. Where it is plus plus, you join O2 minus, that means this one, and where you have minus minus, you join there 2 H plus protons. Okay, and so that will give you the following material. Now out here it is important to notice that this portion, that is this one, is a 1,5 dicarbonyl compound. Okay, so for finding the starting materials of a 1,5 dicarbonyl compound, we have to first of all number them out. Okay, so we number them out as 1, 2, 3, 4 and 5, or we can do the reverse also, something like this. So this is the methyl and that is the O. So I'm numbering from 1, 2, 3, 4, 5. Okay, and now I have to think that I have to break at the 3,4 bond. Okay, so this is the point where I am going to cleave the bond. Okay, like this. And so now my starting materials will be having something like this. So it will be there is a minus sign here, there is a plus sign here because you have broken only one bond. So for that we are having plus and minus sign. Alright, another heterolytic cleavage. So wherever there is a plus sign, you think of removing this proton to find out the Michael acceptor, and this is your Michael donor. This is your Michael acceptor. So over here where there is a minus charge, you just add there a proton. Okay, and so your starting products will be as I have shown over here. Now if you compare, you will see your correct answer over here is option B. Okay, next question is X in the following reaction: 2-methyl propanol, formaldehyde is in excess, calcium hydroxide is a weak base. Okay, that has to be kept in mind, and that is the most important part. So when in case of weak bases, it will not promote Cannizzaro type of disproportionation reaction. Rather over here, we will say aldol type reaction is more preferable. We have a alpha H proton over here. So what will happen over here is this base will take up this proton, and we know formaldehyde is more reactive than 2-methyl propanol. So over here this minus charge will now make a nucleophilic attack over here, all the steps being reversible in nature. Something like this intermediate will be formed, which will add a proton, and this type of a intermediate aldehyde will be formed. Now since there is an excess amount of CHO, HCHO, so over here now what will happen is this molecule and the formaldehyde both do not have any alpha proton, so a Cannizzaro type reaction will now take place over here, in which the OH minus will make an attack over here, which will go like this, and this will give you an intermediate of this type. This will come back, so this will now make a nucleophilic attack on this particular carbon, that will open up. So ultimately what you are going to get over here is OH, H, H, 2 methyl groups, OH, proton exchange means this will now become OH. So this is basically your, I would say, 2,2-dimethyl 1,3-propanediol, and that would be our correct answer over here. Along with that, another side product will be formed, which is obviously the formate ion. Okay. Next question: among the following, among HCl, HClO, HOClO2, HOClO3, which cannot undergo disproportionation reaction? So we will say as a theory that disproportionation does not happen when elements are present in their present in their lowest or highest oxidation states. So if we check for HCl, it is Cl-1, which is the lowest oxidation state possible for chloride. And this one, that is HOClO, it is present in oxidation state plus 3. This is present in the plus 5, and this is present in the plus 7. So out here we will say that option 1 and 4 are the correct options. Question 6 given: the electronic transition in He that will occur at the same wavelength as that of the N2 to N1 transition in H atom. So for this the formula is so this is for the H atom, let's say, and that is going to be or we can say lambda is nothing but it is 4 by 3. Now for the He plus ion, we will say 1 by lambda, okay, RH ZHE plus square 1 by Ni square minus 1 by Nf square. So this will be equal to 3RH by 4 only when Ni is 2 and Nf is equal to 4, and so the correct option over here is going to be D. Okay. The next reaction given is P, which we'll discuss in the next slide.